Our first task, starting with the mini project that you worked on last lesson, is extended by way of deploying it. To follow along, navigate to the SageMaker deployment folder and then into the tutorials folder and open up the IMDb Sentiment Analysis XGBoost web app notebook. As in the mini project, we will start by downloading the data and then doing a little bit of processing. So we start by reading it in. If you remember from the mini project, one of the ways that we converted our reviews to a list of words was to use Beautiful Soup and NLTK. We used Beautiful Soup in order to remove any HTML formatting that may have appeared, and we use NLTK to stem the words. Here we're going to take a bit of a more simplistic approach, and we are just going to remove any punctuation and any HTML formatting that will appear in our reviews. And we're just going to do that by using the Python 3 regular expression module. There's a reason that we've chosen to simplify this method quite a bit, and it has to do with some of the technology that we'll use later. In particular, this makes using Lambda much easier. So how does this method work? Well, suppose we start with this review right here. As you can see, there is some HTML formatting, and we have some punctuation here and here. So review to words will then clean that up, and what we're left with is a cleaned version of the review. So now what we'd like to do is do that to each of the reviews in our data set. Now that that's done, we need to take our cleaned reviews and we're going to encode them using bag of words. What that means is that we are going to look at all of the reviews in our training set, and then we will collect the most frequently appearing words, and then we will encode each review as a vector, where each entry in the vector tells us the number of times that particular word appears in our review. Notice that the vocabulary size that we use here is 5,000, which means that we are only going to track the top 5,000 most occurring words in our training set. What that means is, once we have encoded a review using the bag of words approach, we should end up with a vector which has length 5,000, which we do. Next, we need to move on to uploading our datasets to S3, and we do that in the standard way. First, we will split our training set up into a validation and training set. Next, we will save the test, train, and validation sets to disk using pandas. And to save a little bit of memory, we will set the variables that held onto our pandas data frames to none. Keep in mind that the notebook instance that you are likely to be using does not have a lot of RAM available, so if we just sort of let these data frames hang around even though we don't need them anymore, we could end up running out of memory, which can lead to some sometimes difficult to diagnose issues. Once that's done, we are going to use the SageMaker upload data method to upload our test, validation, and training sets to S3. Next up, we create an XGBoost model in the same way that you did in the mini project, and then we fit the model. Now that the model's fit, we can go ahead and test it by creating a transformer object and then creating a transform job on our test data to make sure that our model is working as we expect it to. And once the batch transform job is done, we can copy the resulting output from S3 to our local notebook instance and then check to see how well the predictions did. Turns out not so bad. All right, so now we are going to extend the mini project in order to deploy it for the first time, much in the same way as we did with the Boston Housing Notebook. Of course, deploying is relatively straightforward using the high-level approach, which is called the deploy method, and wait for SageMaker to set up our virtual machine and get it running. Now that SageMaker has finished setting up the virtual machine, which we are using to deploy our model, we can test the model again. We should get the same results that we got when we created a batch transform job. However, we're going to test it again to make sure that everything is working as we expect it to. So first, in this case, because we're using the high-level approach, we can use SageMaker's built-in serialization methods. We just need to make sure that we tell SageMaker what format our model expects to receive data in. In this case, for an XGBoost model, it expects CSV data. Now, since our testing data is too large to send in a single invocation of our endpoint, we need to split it up. So we split it up into chunks, and then we collect all of the output. Then we send our test data off to our endpoint to see what our model thinks. Now that our model has finished performing any predictions it needs to on the test set, we can take a look and see how well we did. Good. We got the same result as when we created a batch transform job. Now we deployed our model in this section so that we could test it to make sure that everything was working. We're going to have to do a little more work before we can actually use our endpoint in our simple web app. So for now, we're going to shut down the endpoint that we've deployed. It's a good idea to do this if we're not going to use it in the near future, because remember that the cost of deploying an endpoint is based on the length of time that it's running for. So if you don't need it, shut it down.